Hello, greetings. I set up a test. The goal is simply to move the motor, the JMC motor with EtherCAT interface. And I have a PC, I installed LinuxCNC, I installed an EtherCAT master and set up one motor as the first participant in the EtherCAT bus, so to speak. Yes, very rudimentarily parameterized with a generic driver to see if it can even be moved. And before I activate the whole thing now, I'll twist the motor shaft here, and then we already see the first, I would say, good thing about such a system. I see that the x-axis or the x-coordinate in the CNC control moves. This means, conversely, after referencing, the motors can also be disabled, so to speak, so that I can turn them without control, and then I can even move the axes without losing position, because the motor constantly transmits the position of its shaft. So that's that, and now I'll go into the machine and turn it on. So now I can no longer rotate the motor shaft. So, and now we can jog the motor a bit. I do this by pressing plus and minus, and we see the motor shaft moves accordingly forward and backward. That can also go a bit faster. We also see here in the program preview how the tooltip actually moves back and forth. So conversely, I can use the motor here without any EtherCAT hardware in any way, shape or form. So I just have a PC, I have LinuxCNC, there's a software EtherCAT master running, and then I get the slave information with LinuxCNC via the software EtherCAT master and send it back there. Yes, I'll power down the motor again. As I said, a small advantage is that we receive position values here. We also see here that torque values appear, in other words, force values. If I now switch the motor back to control, theoretically, if I now apply some force to the shaft, we see a 200 here in the second parameter. And when I push in the other direction, 65,000. So that means you could even integrate load indicators into the interface, like graphs that show the load on the axis during milling. Just speaking hypothetically, but that would certainly be conceivable. But as I said, what I also have on other milling machines through glass scales is that the rotational movement is transferred to the motor via the lead screw. If I somehow move an axis, then I don't suffer any position loss as long as the system is on and the software is running. If I naturally turn off the system and then rotate the axis, then I naturally have a position loss. That's why you always have to reference at the beginning. But fundamentally, a highlight of such bus systems in general is that you can transmit far more information than just for example, step direction or so, or the detection of a sensor. Here you have far more possibilities. Okay, I don't want to drag this out. That was the first step. The next step must be to set everything up properly again with 3 motors, really test the maximum, let's say, limits there, see if the whole thing runs stably. As I said, this is on the fly, a small setup that represents little. From that perspective, I think a few more steps are still necessary. But as I said, as a first step, the motor moves without any fuss. That's why I'm optimistic that it will also work stably with 3 motors. Okay, then I say, or hope that you got a bit of insight or a bit of courage that such a system can indeed work. Okay, then I say, see you soon. Bye.